Hey, my name is Anirudh, and my group mates are Swara and Sai Ritvik, and we are group number 74, and our project is Neural Networks Part Speed Control. This is our poster. So our overview basically is we built a single shot detector, which is basically something that defines a single region of interest and tries to define the output from the image or the video or the real time input that has been given to it. So what we've done is we've created a neural network from scratch, which basically recognizes speed limit signs and traffic signs, and recognizes what they say and what are the numbers presented on it. So we've basically tried to get into doing some real time recognition of said traffic signs using like training and testing, and we've used different metrics for comparing our results. So we've obviously taken some inspiration from how Tesla models its cars for the autonomous driving that it does, and it also works on a complex neural network that not only takes into consideration traffic signs and road signs, but also people walking around the road lanes and turns and everything that is in the surroundings basically. And we've just tried to emulate that model into our project. This is the literature that we followed. We followed a couple of projects, and we've also followed the YOLO project the model that we've actually used in our project. This is the implementation tools that we have used basically. So as any intelligence model is concerned, we have 5 steps in it where we've collected the data from Google and Kaggle. As far as augmentation is concerned, we've done this using image processing and computer vision techniques. What we've basically done is we've tried to blur images, we've tried to rotate images so that the model has newer data to train on and newer variations of data to train on. So we're hoping that we could get a good balance of bias and variance when we train our models. As far as annotation is concerned, we've used something called as label IMG, which I'll be talking about in a few minutes. The model creation is done using a combination of Tiny YOLO version 3 and the Darknet framework, which is basically a framework in C and CUDA. So it's used for GPU training and CPU training. And YOLO is basically the model that we've trained using this particular network. And all of our testing is being done using Python. This is the data set that we've used, and if you can see, there are faint green colored boxes. These are the annotations that we have created, and the values that are present below, they represent the object class, the and the region of interest that is defined by that particular object in the image. So this is a system design that I just spoke about. We collect data, we divide it into classes, and then we annotate it and give it for training and testing. Now, coming into the next part or the complex part of our system design, once we train, we give it to the model like Tiny YOLO and Darknet, and we've defined certain configuration parameters here, like how is our batch size going to be changing, how is our learning rate going to change, when do we pass our global minima, and what are the weights produced. So basically, we do all of this. We produce a set of weights and we test our model on it using our code. And then we've basically defined a metric called confidence. So if our confidence is greater than 50%, we go ahead with our output. But if it's less than 50%, we go back into the loop and go back to data augmentation and try to get better results from testing. So this is how our data is given in. Like, this is just a static data, and this is the output that we've received. So as you can see, both of the outputs are detected correctly with a confidence of 1, which is 100%. So that is a good sign that our model is working correctly. Now let's talk about real-time detection. So our model is working well for static detection, but what about real-time detection? So videos are nothing but frames, but in this case, we're basically taking one frame and processing it, and then taking another frame and then processing it. So we've tried to emulate that as well, wherein we've taken real-time detection into consideration. And I have a video for you where you can see real-time detection happening. So this is just an image that I've taken of a speed limit sign, and on the left, I'm going to turn on the camera and give the image as an input, and you can see that there's a bounding box that's been created with the speed limit 40. So our real-time detector is working well according to what we've planned. So our model is working well for both static and for real-time data. So that is a good sign for us. Now, if we talk about how we can how we can improve this, or how what is the scope of this project. So obviously data improvement, data augmentation, getting more data into it could be a good approach. And tiny olo 3 is a single shot detector using a cnn that takes into consideration multiple regions of interests, could be something that could be tried for. And I think that would help us create a strong reliable neural network that can help us in achieving the goals of this project even further. So that's it for our project. We hope you liked it. Thank you so much.